Thank you guys for coming. So yes, ChatGPT did create that title, but yeah, it's a great title. It's a very relevant topic. Not everybody, like Flow, has, I guess, the big Prometheus streaming, real-time data stream coming through their pipeline. There is sort of legacy data coming through as well. So really this talk is about what does it mean to be real-time and just understanding what that really means. So a little bit about me. So Johnny Mirza, Solutions Architect at Confluent. I've been there for 3.5 years now, I think, so around about that time. I was working at Confluent when everybody was calling us a wiki, right? We were confused as Confluence, but Confluent is the event streaming platform with Apache Kafka. Yeah, so I've been at Confluent for 3.5 years now, and enjoying bringing event streaming out into the enterprise to move away to batch processing and get better access to real-time data. So a quick little agenda. So how to become real-time is almost to become more event-driven, to start to use events and to start to use event-driven data in real time to make that data highly available. So I kind of want to go through that. I've also got my trusty whiteboard where I want to run through a bit of a whiteboard scenario as well. And then I want to walk through a demo of Confluent, from getting data from on-premise into a Confluent Cloud scenario, and then using ClickPipes to write the data into ClickHouse Cloud there as well. So just going through the age-old analogy of the more data, the better. So as storage became cheaper, obviously, we started to throw more data at storage systems, data lakes, databases, all that sort of stuff, to throw as much data as we can into the particular type of lake. But then what we found was it was quite difficult to consume that data and to read that data out as well. So as we start to get into the age where we are today, now it's really about getting access to the data in real time, in motion. And I've got a really good example of this. I guess there's two types of people in the world. There's, everyone's got their emails and they're not using Slack for emails and communication. So there's the type of people that will address an email, or as soon as an email comes through in real time, they'll go and action that and read that email and then make an action, file that away. Whereas there's the other type of users where they've got a large amount of emails that are sitting there. It could be sitting there for months and months and months, and eventually they'll get time to go back and read those emails. So to me, there's not the right or wrong answer. There's kind of the batch versus the streaming, or the real-time versus getting the data out. So I like to use that analogy of how to get access to real-time data. And as you can see, there's a lot of these data stores are built on top of databases. And being a ClickHouse event, I'm not going to debate OLAP versus OLTP databases. This is really just about getting data into a database, but ultimately the data lives at rest. So the data is living there. And then when you need to query that data, you have to pull that data back. And there's some latency, and there's some processing and some complications around pulling that data back, especially as you get more and more data flowing through the system. So fundamentally, throwing data in or ingesting data into a database could be easy, but as soon as you start to query that data, that's where it becomes complex and difficult and costly from a compute perspective. And if we look at the world of integration, and this is actually a good example of modern integration of what it could look like to consume data from lots of different systems, whether it's different data sources where there's ingestion frameworks where you've got your ETL, you've got to transform the data, and then potentially write that tool into another sort of operational system to consume that. But there's lots of communication that needs to happen here, lots of processing pipelines. I've actually seen worse scenarios in this, where there's lots of just SFTP and file transfers around organizations, which could be hourly, daily, monthly type scenarios where they're pushing data through different types of systems. Whereas if we look at it from a Confluent perspective, in Confluent, for those of you that are not familiar, Confluent was created by the founders of Apache Kafka. And Apache Kafka is essentially a log system where data is stored within a log file in a distributed system, and basically is the foundation of all types of data that comes through. So the log is a append-only log where it consumes data, and data is written to this log where it can be scaled out to almost store data infinitely if needed. It's also based on a pub-sub methodology. So to get data in, you're producing data into this log, and then to consume data, you're consuming that data out. So ultimately what we're doing is Kafka's been created to move away from point-to-point communication using REST APIs to go and pull data out and start to use a Kafka protocol to go and consume that data and then write that data into this log that can be reused many, many times. And if we look at Kafka's been around for quite a while, it's really about creating a streaming platform that enables you to, instead of having a point-to-point sort of batch process and consuming data from a lake or a database, it's really about turning those data sources to use a Kafka-type protocol where it's storing that data, whether it's using a connector, whether it's using a Kafka producer, writing that data into this log, being able to process that data, provide governance around that data as well. So where you've got management of the schema, for example, depending on the data type, whether it's Avro or Protobuf, for example, running stream processing on top of that data, and then also sharing that data out to multiple different consumers. So as the flow example, they're using the data from Prometheus into ClickHouse for analytical and building use cases. With Kafka, you can use the data for many, many use cases. Analytical for your use cases around creating new microservices on top of that data as well, using asynchronous services there as well. So it's being able to share that data and create these streaming pipelines using Kafka. And you can shift the language to become more streaming integration. So instead of point-to-point communications, it's more about streaming applications within your Kafka environment. So everything becomes a streaming use case almost, where you can stream from source to destination or source to multiple different destinations, providing that governance around the data as well, by providing things like role-based access control and authentication around it. So really it's about moving away from, so there's a lot of clicks in this slide, point to point and lots of integration connectivity. We've got lots of source systems, point to point, talking to many different targets, lots of reusing the data, lots of communications, lots of pulling that data back from lots of different stores, and then moving that data into more of a streaming solution where you ingest the data once, but then you consume many, many times. And that's how you do that using the Kafka protocol as well. Alright, so I just want to go through the slides quickly and then jump into a whiteboard and a demo. So fingers crossed this all works really well. Okay. Apologies for that. Yeah. Okay. I'm just going to put the mic down for this one. Alright, so in this scenario, if you guys can hear me okay, so what we're going to go through is essentially a bit of a scenario of how this demo I'm going to show you was planned out. And what we've done is we've created this using just a virtual whiteboard. So as an example, let's say I've got an on-premise system. So there's an on-premise workload running there within an on-premise data center, could be managed within your own VPC. But in this case, I've got a Postgres database, for example. Might have an Oracle database there as well. So I'm collecting data, could be another system within an Oracle database. And then for this scenario, I'm actually going to use Zeek as well. Zeek is an open source tool that allows you to collect packet data or flow data from within a network. It's really cool if you want to use it at home. You can monitor activity, Netflix, see when your kids are on YouTube, for example, instead of doing homework, all that sort of stuff. It's all fun and games. But Zeek is actually a really cool tool that you can use for collecting that information. And then from there, the aim is to really move the data to the cloud. So that's migrate the data from on-premise and then shift that to a cloud scenario. And then we're ultimately, in this scenario, the data is going to end up in ClickHouse using sort of Kafka connectors, for example. So we're going to have a connector that connects to Kafka Cloud, so just leave that there. And then essentially we're going to have potentially some private networking that's going to connect all of that data into the on-premise to the cloud. So there's lots of different networking type scenarios there as well. But if I go back on-premise, so I've got my Postgres database and I've got my legacy database. There's a few different ways that we see this play out, but typically you'll have a Confluent platform or you'll have a Kafka deployment on-premise that's collecting that data. You could have legacy workloads, legacy dashboards that's running on-premise. And then you might have a Confluent platform or an open source Kafka that's running on-premise there. You might also have a Kafka Connect that's running on-premise, and that Kafka Connect will go back and say, for example, do some change data capture on the two databases, whether it's your Oracle database here or your Postgres database. So I might be doing some change data capture there. And then I'm also got this Zeek producer that's producing data directly into Confluent platform on-premise. So now I've got all this data that's kind of running on-premise. You can do some, if you're not familiar, there's a thing called a simple message transforms. You can do some basic transformations within the stream there as well. So you can, mask some data or filter some data or do all that sort of stuff. But then, ultimately we've got Confluent Cloud running there in AWS, for example. So that would be a managed service running in AWS. And then we can basically push the data from, you can run Kafka Connect. You don't actually need the on-premise. You can actually just run the Kafka Connect on-premise. And then you push that data into Confluent Cloud there as well. And then once the data is in Confluent Cloud in this particular scenario, there's also something called KSQL DB that allows you to run stream processing on top of that data. So now I've got topics coming in from Oracle, for example. So tables coming in, change data capture. I've got some topics coming in from Zeek, and then I've got some topics from Postgres coming in there as well. So now it's about running KSQL DB to go run some persistent queries on top of that data there as well. So now I can use KSQL to do that. Also, maybe create some aggregations. So I want to aggregate some of that data in real time. So I'm pushing this data and I'm aggregating this data in real time. I'm not pulling it with KSQL DB from a database. It's actually reading that within stream as a Kafka consumer, and then it's aggregating that data. And then from there, there's also some filtering and transformations that you can do within those topics there as well. So creating streams upon streams on top of that data. And then enriching that data, doing some joins with the aggregate there as well. And finally, now I want to put the data into ClickHouse, for example. And there's a couple of different ways of pushing the data into ClickHouse. So there is an open source ClickHouse Kafka connector that you can use to go and spin that up. It's a self-managed connector that you can run in Kafka Connect. And then basically that consumes the data from Kafka and then pushes that into ClickHouse asynchronously. That's absolutely one way of pushing that data through. I'm kind of not going to show this, but you can also sync the data into another S3 bucket or another sync as well. So you're fanning out the data from on-premise into another S3 bucket. And also, there's also a REST interface. So not many people kind of use this very much, or have known this very well, is there's a REST interface that you can use on KSQL DB. And what it allows you to do is to basically, once you've created that aggregate, you're essentially creating a real-time sort of materialized view on top of that data. So, so now that I've got that materialized view, on top of that, there could be a web service that can go and consume that data from that materialized view using a REST API. So any user can interact with that data set using a REST API there as well. And finally, the other integration, I think there's a couple more, but the other integration that I used, only because it was easier, was ClickPipes to push that data into ClickHouse using ClickPipes. It's just easy to go through. I don't have to manage my own connector. It's quite easy just to use that. ClickPipes, it's a little bit different. It's not a connector, so there's no managed connector using ClickPipe. It's more like a Kafka client that kind of lives in ClickHouse Cloud. So I just use that to push that data into ClickHouse. And then from there, obviously, the user can interact with that data and run analytics on top of those use cases there as well. All right, so that's kind of what I had for the whiteboard. We'll definitely do more of those later. But yeah, just from a real quick demo perspective, this is what it actually looks like. So this is Confluent on-premise. It's running in AWS, but it's Confluent on-premise. It's the self-managed version. So that's something called Control Center. Within Control Center, I've got a data generator that's simulating a whole bunch of Zeek data. So for example, I've got some DNS logs, I've got firewall logs, I've got some Splunk data that's going through being generated. So all this data's being pushed into this particular Confluent platform instance, where I can see, for example, that all that information coming through, for example. So that's all on premise. If I just flip over to Confluent Cloud, sorry, I have to sign into this again. Into now in 5 minutes. So now Confluent Cloud, which is the cloud portion running in AWS, which is the fully managed Confluent Cloud version. So I need to get that data from the on-premise to Confluent Cloud. Confluent Cloud is actually quite cool. There's always new features. Every time I log in, there's a new feature, there's a new button or something in the data portal. I'll look into that later. But essentially, if I go to my cluster link over here, and a cluster link is a connection that is similar to sort of Kafka replicator, Confluent replicator, that is going to consume data from my on-premise cluster. So I've got this Zeek cluster that's running on-premise, which is the one I showed earlier. And it's consuming all of these, well, it's actually mirroring all of these topics from the compute instance or the Confluent platform that's running on-premise. So you can see that, I've got DNS, the same sort of data that's all pushed through Confluent Cloud now. And then if I go back, I went to a full demo of Confluent, so it might take a little bit of a while, but essentially what I have here is I'll just go to my production cluster, so I know that's where the demo lives, and I actually put it just coincidentally into a cluster called my Flink cluster that I had running. Not using Flink for this scenario, but it is using just the Flink cluster there. But if I go into that cluster, I'll be able to see a whole range of different things. So that's where my topics have been mirrored into this particular cluster. So now I've managed to generate some data, I've pushed the data on-premise, done some filtering of the data on-premise, and then pushing that data using cluster linking into Confluent Cloud. So it's the exact same data that's being mirrored, not replicated, it's being mirrored into Confluent Cloud. So that's the cluster linking feature within Confluent that pushes that data across. You can kind of see a little bit of a view of this. It's not fully finished yet, but there's a feature called stream lineage. Right now it's only within the cluster, but eventually it will be across multiple clusters where you can see the full lineage from end to end, including all the cluster links. But now I can see, for example, I've got some topics over here that have been mirrored, and then I've got this consumer over here that's running. That consumer is actually the ClickHouse consumer. And if I pivot over to ClickHouse, so what I've got here is, I'll just go to the import section. You can see here it was easier to run ClickPipes rather than having a self-managed connector. But essentially I ran ClickPipes, quite easy. All you got to do is basically select your cluster, whatever the cluster is, and then just put in some credentials, put in the topic name. And obviously if the networking is all there, it will connect to that cluster, and then it will start pulling and consuming that data back into ClickHouse. So so what I have here is some queries that we typically sort of run in the Confluent world on KSQL. I've decided to run them on ClickHouse. So for example, here's some flow logs that you can view and see that data sort of pushing through. This query I don't think will ever end because the data is constantly streaming through there, so there's no sort of stop all to limit that query or work laws. So basically I'm just, in this particular scenario from a security perspective, I'm trying to look at or do a count of all of the established connections that didn't come from origin but were like an origin address, like a local type of address. So from an internal network, so you can see that these particular connections over here, 204 times, it actually connected to a particular host on my internal network, which is quite clever to see. I mean, that query ran in 100 milliseconds, it was 2.8 million records. If you need to optimize that further, then I'm not the right guy for that, so someone else. But pretty fast to be able to see that. And then, even being able to run sort of, and this is all new to me because I do a lot of this on Kafka, but being able to run like a tumbling window over a 5-minute interval. So in this particular scenario, I'm just looking for, just doing a count of all of the queries by source IP address over a 5-minute window, where I can run that data through and I can get that information back from this particular data source. Here's a really sort of cool security one. I even created a materialized view around this. Essentially being able to join some data from a known bad actors query list with the actual live queries being run in DNS data. So I can run that query and then I can see that there's a whole range of this IP address talking to a known sort of bad ad server there. So that's quite cool. And then, finally, I come from a Splunk background, so I thought, kind of wanted to do some Splunking of some data here as well. But just being able to, for example, run a aggregate. Where's the aggregate query? So I'm just running a 1-minute aggregate of all of this data coming from this particular Splunk event using some pull regex just to pull out some fields over here. So now I just want to aggregate some data that's coming through from Splunk into a sort of 1-minute window. And because it's running that regex, I imagine it's quite slow there as well, because it's doing that. Let that run. But now I can see, for example, this particular host has 664 messages being created within that within that 1-minute window. So that's created 664 messages in that 1-minute window. So I guess from a licensing perspective, you would have to send that message 664 times to the Splunk server. But when you aggregate the data, well, you can only send it once. It's still a total count of 664, for example. Okay, so that's my quick experience with ClickHouse there. And just to wrap up, some quick learnings around today. So data sources are growing, starting to see lots of real-time value. The current approach to integrations, especially with file transfers, is really not sustainable. Running ClickHouse queries, running that at milliseconds worth of time, that's great. But if the data is an hour old, then you kind of need that data to be as real-time as possible. And that kind of leads to the Kappa architecture as well, so being more event-driven rather than sort of batch-orientated. And then fast data always means slow data. So that was kind of it for my talk. If you want to catch up, so that's me on LinkedIn. And also just a quick little Peter, if you don't mind, just a Kafka user group as well. So if anyone wants to join the Kafka user group, please feel free to do so. That's something that Confluent hosts as well. All right. Thank you.